So let's talk about some arithmetic and geometric sequences. I hope you're happy, because I'm happy too. So an arithmetic sequence, that's a sequence when we just keep adding a number. It's an addition-based sequence. And the number we add is called the common difference. We use the letter D to represent it. And D is just the difference between two consecutive terms. That's what's meant by right here. We just subtract two consecutive terms, and that's our common difference. If that difference is positive, then it's an increasing sequence. If it's negative, it's a decreasing sequence. So basically, our terms, we start at u sub 1. To get the second term, we take the first term, and we add that difference. And we just keep adding that number. So the third term is going to be the second term plus another d, or let's call this u1 plus 2 times d. If we want the fourth term, u sub 4, we're going to add together 3 of those differences. And this is just u1 plus 3 times d. So noticing that we always add one fewer common difference to the term number, what we can do is we can say that we can express any term of that sequence by this formula, if you will. To find any term, u sub n, take the first term, add that to the product of the difference and the value of n minus 1. So let's play with that a little bit. So for example, in this sequence to the left, I want to find the value of the 21st term. Sure, I can keep counting it out again and again and again, but let's recognize a couple things. First of all, our first term is negative 7. The common difference, it looks like we're going up by 2 each time, so our d is 2. So then, if we want the 21st term, all we need to do is take our first value, negative 7, and add to it 21 minus 1 times our d value of 2. So 21 minus 1 is 20, times 2 is 40, minus 7. So the value of the 21st term of that sequence is 33. You want to try the next one? It looks scary, but it's not. So if I look at my common difference here, 4x, I'm going to add another 4x to get 8x, add another 4x to get 12x. So if I want the 18th term, u sub 18 is going to be my first term plus 18 minus 1 times my common difference of 4x. So that gives me 17 times 4x. I think 17 times 4 is 68, plus another 4 is going to get me up to 72x. So there's the value of my 18th term. And because this is an equation, we can also solve the equation a little bit as well. For example, if we want to know how many terms are in this finite sequence, what I know is that u sub 1 is negative 22. It looks like I'm increasing by 4s, so d is 4. My last term, I don't know what the number is, I'm going to call it u sub n, is 48. Can I solve this equation for n? I'm going to write 48 equals negative 22 plus n minus 1 times 4. Now I just have to solve this equation. So if I add the 22 to the other side, I'm going to get 60. Let's divide both sides by 4. So in this sequence, there are 16 total terms. In this bottom one here, I know something about term number 6 and term number 11. And I want to get up to term number 15. Well, I don't really know what the common difference is, but I know the difference between 34 and 4. And that's going to span term 11 to term 6. So it's almost like a slope, if you will. So I get 30 over 5 which equals 6. That's my value of D. My common difference is 6. So now I got like a couple different ways I can approach this. I don't know the first term, so what I could do is I could use one of these terms. I could say, like, if I know u sub 6 is 4, the sixth term is 4, I could solve this equation for, I could solve this equation for u sub 1. And if I believe if I do that, I'm going to get that u sub 1 equals negative 26. And then I can go from there. Because now I know I want the 15th term. So u15 equals negative 26 plus 15 minus 1 times 6. And I think when I evaluate this, I get that the 15th term is 78. But there's another way to do it that's a little more creative. So what we'll do is green, because green is creative. I know that from u6 to u11 is counting up to a total of 5 terms. So if I call u sub 6 u sub 1, then u sub 15 is really u sub 10. So I'm kind of forgetting about all the first 5 terms and starting at term 6. And then I can solve this equation. I can solve that 4 equals, well, not 4 equals, let's erase that for a minute. I'm going to find my 10th term in this case. So now I'm going to pretend my first term is 4 times 10 minus 1 times 6. And this is going to equal 58. And you're saying, wait, that's different than 78 from before. That's because I did that one incorrectly. I did some bad arithmetic, and I got that to be 58. How come you didn't say anything to me? How come you didn't catch me on that? Hey, but that's how we use arithmetic sequences. We love that little formula there. Let's proceed and talk about geometric sequences. So geometric sequences based on a multiplication. Instead of having a common ratio or a common difference, we have a common ratio this time. And just like the common difference was the difference between the two terms, the common ratio is when we divide the two terms. And we call that ratio R. We say instead of increasing or decreasing, we say if R is greater than 0, the sequence diverges. It just kind of goes off forever. But if the R value is less than 0, it will converge. It will approach a certain number. And we'll get more into that later on. But again, if we talk about the terms of this sequence, again, the first one is u sub 1. U sub 2 now, because it's multiplication based, is u sub 1 times R. The third term is u sub 1 times R twice, or u sub 1 times R squared. And I bet you see where I'm going with this. Then the fourth term is the first term times the ratio cubed. So what we're going to get there is that for any geometric sequence, this is how we could find our specific terms. So let's play with a couple. Like we did before with the arithmetic, we'll use the geometric one. If I want to find out my value of R, my ratio is going to be a term divided by its previous term. And I think you can tell by the terms of this sequence that we're dividing by 2, so we're multiplying by a half. So now if we want to find the 12th term, the 12th term is going to be the first term multiplied by the common ratio, and the exponent's going to be 12 minus 1. So let's go to our calculator and figure that out now. So if we do 40 times 1/2 to the 11th power, how about the fraction 5 over 256? And yeah, we can do with x's as well. Remember, to find the r value, we want to divide a term by its previous term. 6x squared divided by 3x is 2x. So then we want the eighth term. The eighth term is going to be the first term multiplied by the common ratio to the exponent of 8 minus 1, or 7. So let's figure this out. If we do 2x to the 7th, 2 to the 7th power is 128. So we're going to do 3x times 128x to the 7th. So u sub 8, if we do 128 times 3, we get 384 x to the 8th. That would be term number 8. Here's an interesting little situation as well. We have a sequence where the first term is 81 and the sixth term is 1 over 729. Let's see if we can find some of the other values. So the one thing that I don't know is my ratio r, but I have enough to solve for it. Because I know that the sixth term is equal to the first term times r to the 6 minus 1 power, the fifth power. So that means that 1 over 729 is going to be equal to 81r to the fifth. So if I solve for r in this case, I'll first divide both sides by 81, and I'm going to get 1 over 729. And I'm going to leave it all like this. All of that equals r to the fifth. So then I have to take the fifth root of both sides. So my value of r is going to be the fifth root of the fraction 1 7/29 divided by 81. Like I said, that's a calculator thing. Let's go to our calculator and do that. So on here, I want to go Control and then the caret button to get my root key. And I want the fifth root of, and just to help me out a little bit, I'm going to do the fraction template as well. And I'm going to do 1 divided by 729. There's my numerator. And I'm going to divide that by 81. That's my denominator. So that gives me an r value of 1/9. All right, so r equals 1/9. So let's start finding some of these terms now. The second term is 81 times 1/9, which is just 9. The third term, if we do this recursively, it's the second term times 1/9, which is just 1. And the fourth term is the third term times 1/9, which is just 1/9. So hopefully you see in this video how we can use those formulas for the arithmetic and the geometric sequences to really just solve equations and find whatever values we need.